Welcome back to SciInsights. Don't forget to subscribe.
The first living organisms appeared on Earth at least 3.5 billion years ago. To us, they would have seemed tiny and insignificant. Yet they were extraordinarily complex compared to anything else that had ever existed. Over the next 3.5 billion years, they would diversify and evolve. About 600 million years ago, some started to combine. Over time, they formed multicellular organisms like trees, mushrooms, frogs, dinosaurs, or even the first small mammals, which probably looked a bit like mice. When the dinosaurs were wiped out by an asteroid, mammals prospered, evolving into a great range of new species. One group lived in trees and ate fruit. They had hands, stereoscopic vision, and unusually large brains. These were our ancestors, the primates. Our own species, Homo sapiens, evolved about 200,000 years ago. Now, we treat the appearance of humans as a new threshold because we would eventually create entirely new forms of complexity. Today, we have become the most important force for change on the Earth's surface. We are the first species in 3.5 billion years that has had such power. What makes us so different? For this threshold, powerful brains are one ingredient, but it's not just a matter of brains. Many other brainy species exist. They include dolphins and chimpanzees and crows. The other critical ingredient was the development of symbolic language. This enabled humans to share their ideas with each other very efficiently. Human communities grew and interacted, creating the perfect conditions for something new: the ability to learn collectively instead of just as individuals. Ideas and knowledge accumulated generation after generation, and human technologies became more and more powerful. As knowledge accumulated over time, our control of resources and the environment increased and accelerated, leading humans towards two new thresholds that would have a huge impact on our planet.
Humans have been on this planet for about 250,000 years, and for most of that time we lived in Africa. But then soon after 100,000 years ago, humans began to move out of Africa in a series of migrations that took them eventually all over the world. In so doing, humans had to use collective learning to come up with all sorts of adaptive strategies as they moved into environments that they had never experienced before. Today I want to consider this Stone Age with you, this Paleolithic era, by asking four questions. Firstly, how did humans survive in the Ice Ages? Secondly, what do we know about the chronology and geography of these migrations? When did humans leave Africa and where did they go? Thirdly, let me give you some examples of Paleolithic lifeways, how humans actually lived. And finally, let's consider the question of impacts humans had on the environment during the Paleolithic. Firstly, this question of Ice Ages. Over the last 2 million years or so, the Earth has been subjected to about 20 different ice ages, each lasting around 100,000 years. The last two of these occurred during the Paleolithic era, at the very time that humans began to migrate out of Africa. Great ice sheets covered large surfaces of the Earth, and even where there wasn't ice, forests died out, there was frozen tundra and dry deserts. Imagine trying to survive in an ice age. Conditions far worse than you can see me standing in right now. The most important adaptive strategy humans came up with was the controlled use of fire. We know from evidence in Africa that humans were probably using fire about 130,000 years ago at the Clyces river mouth site. Then we've got very good evidence from the Colombo Falls in Zambia of controlled use of fire to cook animals, to harden tools and so on, between about 110 and 60,000 years ago. So fire, critically important adaptation. At the same time, humans came up with much better clothing, with tightly stitched seams, with far more impressive technology, much better spear points and so on. And even more impressively, the Ice Ages may have driven humans to adapt art. Symbolic art begins to appear on cave walls during the Ice Ages. And also we assume that complex symbolic language also appeared at this time as an adaptation to these extreme conditions. So in terms of the chronology and geography, we have evidence of humans leaving Africa about 90,000 years ago, 90,000 BP. By 60,000 BP, that means before present, humans are living in East Asia and Southeast Asia. 10,000 years later, they've made ocean crossings across sounds like you can see behind me here to Australia. By 35,000 years ago, humans are living in the Ukraine. And then extraordinarily, humans move into Siberia at the coldest part of the last ice age around 20,000 years ago. These same humans, these mammoth hunters, then made the final great human migration across the Bering Strait land bridge and into the Americas about 15,000 years ago. In terms of Paleolithic lifeways, we lived in very small groups, 10, 20, 30 at the most. We lived as foragers, scavenging fruits, berries, roots, insects, dead animals, and so on from the environment. The use of hunting is somewhat controversial. How sophisticated was human hunting during this period? It's hard to say. A lot of it appears to have been opportunistic, that is, scavenging animals that others had killed, but some of it was clearly very intentional. The Clyces River mouth site again shows us that about 100,000 years ago, humans were driving elands into especially laid traps. 3 examples. The Inuit people learned to use fire inside dwellings made of ice. They constructed sturdy canoes and hunting tools using animal bones, animal hides, and so on. They followed this lifestyle for tens of thousands of years successfully. Humans living in North America came across very hard stone, falsum points, clovis points. These were so effective, tied onto a spear shaft, that they're probably responsible for the annihilation of the mammoths and other large mammals in North America. The sand bushmen of the Kalahari, even today, give us some insight into how humans in desert climates survived. The women gathered using very simple digging sticks and bags. The men hunted with very simple bows and arrows with poison tipped on the arrows. 3 examples. These small groups would occasionally get together with other groups to exchange gifts, ideas, marriage partners. In Australia, these gatherings were called corroborees. So a lot more collective learning would go on here. But having said that, even as humans spread across the landscape, populations remain small, there's no increase in densities, and within these small human groups, collective learning was still very slow. In fact, we estimate that humans probably met less than 500 other humans during their lifetime during this long Paleolithic period. The final question is, what impact did these small groups of humans have? The traditional view is that they lived in harmony with nature, but that view is changing. We have evidence from Australia, from Siberia, from North America of fire stick farming, where Aboriginal people set fire to huge tracts of bushland for tens of thousands of years. In so doing, they radically altered the environment of an entire continent, turning much of Australia into a desert, essentially. The other example of human impacts comes from the extinction of large animals. As humans moved into environments where no human had been before, very quickly all the large animals go extinct. Up to 75% of all the large animals in North America go extinct. In Australia, the figure is 85%. So in the Paleolithic era, this era of amazing migrations, we see the extraordinary creativity of humans having both constructive and destructive impacts on the environment. Humans moved all over the planet, used fire, used tools and so on, proved that no environment was beyond them. But the climate and the small size of these human communities meant that the pace of collecting remained slow. Only with the waning of the last ice age and increases in the size of human population densities did humans cross the next level of complexity that comes with agriculture.
The last ice age ended a little over 10,000 years ago. At that point, human communities in different parts of the world began using a range of new technologies to increase the energy and resources they could extract from their environments. We call these new technologies agriculture, and its development is our 7th threshold. What ingredients led to this threshold? Well, first, thanks to collective learning, humans had accumulated vast knowledge about their environments over many generations. Second, by the end of the last ice age, humans had also settled all parts of the world, and some began to live in denser communities. Populations increased, and some regions, such as Mesopotamia, began to have about as many people as foraging techniques could support. Now, more people meant you had to try to get more food from a given area. So some groups started using simple forms of irrigation, or they planted wheat, or they herded goats and cattle for their meat. These experiments were the beginning of agriculture. Global climates also got warmer and more stable than ever before. These conditions made it possible to plant and tend crops with some confidence that they would yield abundant harvests. Within a few generations, some plants, and even some animals, became domesticated or more dependent on humans. And as animals became tastier or more nutritious or more docile, they became more attractive to farmers. Farming took off and began to spread around the world. Agriculture was really a way to increase the amount of the sun's energy that was used by our own species. So humans began changing the plants, the animals, and the landscapes around them so that they could use more and more of the products of photosynthesis. This energy bonanza led to the creation of villages, of cities, and of huge agrarian civilizations. Eventually, an even bigger energy bonanza would steer human history towards threshold number 8, the modern revolution.
In the last unit, we crossed the 7th major threshold of complexity in this course, agriculture. We saw how, from about 10,000 years ago, small agricultural villages began to spread in many different parts of the world. These were in fact some of the most important human communities that have ever existed. Now at first that may seem surprising, because when we think of human history we often think first of the great agrarian civilizations. We think of Rome and its empire, or we think of the great Han capital Xi'an and its empire. But without the slow spread of simple farming villages, those agrarian civilizations could never have existed. The real key to understanding agrarian civilizations is increasing complexity. Complexity seems to increase as populations increase. But to support larger populations, you need to be able to get more resources from a given area, particularly more food resources. And that's where farming comes in. Thanks to farming, between 10,000 and 5,000 years ago, human populations seem to have increased from about 5 million to 10 times as much, about 50 millions. A lot of those humans still lived as foragers, but probably by 5,000 years ago, the vast majority of them lived as peasant farmers. Now, within each agrarian area, villages began to bud off, both within the core regions and at their edges. So villages began to spread. And at the same time, farmers began to develop new and more productive ways of farming. They began to farm areas they couldn't farm before, they developed new crops, and they began to develop new and more productive technologies of farming. From about 6,000 years ago, some communities began to find more productive ways of using their domestic animals. Instead of just using them for their meat or skin, which you can only do when you slaughter them, they began to use them for products that they develop while they're still alive, such as their fur or their milk or their draft power. Now that was a real energy revolution. A human can deliver perhaps 75 watts of power, but a horse or an ox can deliver almost 10 times as much. And using that power to pull ploughs, some communities began to farm lands that you couldn't possibly farm using just ordinary handheld hoes. And using that power, you could also carry goods in a way that was impossible just for human porters. And finally, these more productive ways of using animals made it possible for so-called pastoral nomads to settle the arid steppelands of Eurasia, traveling nomadically with their herds of livestock. But an even more productive innovation was irrigation. Irrigation is used to farm areas where there's not enough rainfall. If those areas have fertile soils, which a lot of them do, then you can get huge crops through irrigation, particularly if you introduce large-scale, sophisticated irrigation systems with canals and ditches that require a lot of organization. As farming technologies became more complex and more productive, they eventually allowed the creation of larger, more populous and more complex societies, the societies we call agrarian civilizations. This transition seems to have happened first in Mesopotamia, in the lands south of the Fertile Crescent, and also at about the same time along the Nile Valley. In these regions, as villages spread and farming became more productive, eventually there appeared the first really large villages and then towns and cities. In the lands between the great rivers, the Tigris and Euphrates in Mesopotamia, irrigation systems emerged that produced huge crops and supported large populations. And then from about 5,000 years ago, there appeared in the south of Mesopotamia, in the region called Sumer, the first real cities. These had populations up to 50,000 people. They had walled gardens, they had fortifications around them, they had temples, they had palaces, and they had complex irrigation systems. We even have a map of one of them, Nippur. That map was carved in clay about 3,500 years ago. These were the most complex human societies that had ever existed so far. The real key to the creation of cities seems to be the tiny surpluses that peasant farmers produced, particularly as their farming became more productive. What this meant was that it was no longer necessary for everyone to be a farmer. Specialists began to appear, potters and merchants and priests and soldiers. And now something happened that was a bit like something that had happened already 500 or 600 million years earlier with the appearance of the first multi-celled organisms. Individuals got so dependent on each other that they began to need some sort of coordinating mechanism. So potters, for example, needed markets to sell their goods on. Soldiers needed governments that could hire their services. Merchants needed courts to settle disputes. Town dwellers and farmers needed someone to maintain the huge irrigation systems on which they depended. And everyone, frankly, needed someone to organize all of these increasingly complex relationships. As a result, in response to these needs, a class of power brokers appeared. Most of these were men. And what they did was they began to take on the role of coordinating society. In villages, they were probably chosen by those they led who needed someone to do this job. But as power brokers became more powerful and had more resources, eventually they began to hire paid enforcers who could impose their will by force. And now, for the first time, we have true states and true governments. And we also have something else. There has appeared a new type of food chain within human society. Farmers extract resources from the environment, from the biosphere. But above them, there's now a new layer of elite groups who extract resources from the farmers by the threat of force. So now societies develop a whole hierarchy. At the top, there's a small minority of people who are very rich and very powerful, who extract resources from the vast majority of peasants who may make up 90% of society. And in addition, there's always, we find, a small class of menials or slaves at the very bottom of the heap. Agrarian civilizations appeared in many different parts of the world. There were important differences between them. They had different languages, different religious traditions, different artistic traditions, but there were also hugely important similarities. All of them, for example, had big cities. And those cities had what we call monumental architecture: temples, pyramids, palaces. They also had rulers, they had hierarchies, they had tax systems, they had armies, and supporting the whole thing was a large population of peasants, most of whom lived outside the major cities. Agrarian civilizations also had writing, all of them. And this is really important because it seems to have accelerated collective learning. Writing probably originated as a system of accounting as those elites and power brokers who were accumulating more and more resources tried to keep track of their resources. But eventually, the symbols used for accounting could be used to convey all the nuances of everyday languages and generate literatures and history, proper writing. Agrarian civilizations appeared wherever agriculture flourished. So this means it appeared in all the core regions of agriculture, with some interesting exceptions. It didn't appear in Papua New Guinea, probably because the root crops that were grown there could not be stored, and agriculture was not quite productive enough to generate surpluses and support specialists. As we've seen, the first real agrarian civilizations seem to have appeared in Mesopotamia and along the Nile Valley about 5,000 years ago. Some of these consisted really of little more than cities with surrounding villages, but some were huge, including the first Egyptian state, which covered a vast area along the Nile. By about 4,000 years ago, we have evidence of agrarian civilizations in China and other parts of Asia, including Korea, which is where this folk village is. We get evidence of cities also appearing in other regions, such as Central Asia and in Pakistan along the river Indus. Then, by about 3,000 years ago, we get evidence of huge empires, such as the Assyrian Empire. We get evidence of huge empires in China and also in Egypt. The first real agrarian civilizations in the Americas seem to have appeared about 2,000 years ago, just over 2,000 years ago. By 500 years ago, when Europeans first reached the Americas, the Inca and Aztec empires covered a colossal territory. Agrarian civilizations, like the agrarian technologies on which they were based, slowly evolved, spread, developed, got more complex, more populous over 4,000 years. By 1,000 years ago, it's probable that most humans living on Earth lived within agrarian civilizations, and almost all of them would have been farmers.
Human civilizations have been wonderfully diverse, with an amazing variety of unique customs, religious practices, social structures, and technologies. These differences are fascinating, but big history teaches us to look at the past differently, to seek out commonalities and identify patterns that unite seemingly unrelated phenomena. Often this produces insights that are even more interesting. One of the most important patterns we see among agricultural civilizations is the need to expand. Many agrarian civilizations grew to control a lot of territory. The Roman Empire at its peak controlled around 2.5 million square miles. The Persians more than 3 million square miles, and the Mongols a whopping 10 million square miles, with an empire stretching across Asia. Though these empires existed in different places and at different times, they shared a strong drive to expand geographically. And when they could no longer grow, their territories shrank, and eventually their civilizations collapsed. So why was geographic expansion so essential to their survival? Maintaining a state was expensive. Increasingly large populations required more infrastructure, more resources, as well as bigger governments and militaries. Ambitious monumental architecture like the pyramids added even more expense. Because land productivity had its limits, and leaders could face rebellion if they tried to squeeze subjects too much with heavy taxation, there were limits to how much states could grow using internal resources. Thus, growth necessitated taking what others had produced rather than trying to increase productivity within the state. During the era of agrarian civilizations, this type of military expansion was common. We see it in civilizations around the world, with the Persians, the Romans, the Chinese dynasties, and with the Aztec and Inca empires in the Americas. Large professional armies required food, weapons, and complex infrastructures like roads, forts, and defensive walls. All this came at great expense, which itself increased the need for expansion. Some military innovations led to inventions that would advance entire civilizations. Iron is a good example. The hard metal was initially used for weapons, but once iron plows appeared, crop yields increased, and so did populations. Roads, initially designed to move armies, became important trade routes, and building techniques were refined after the construction of so many walls, forts, and watchtowers. Throughout this era, borders were constantly contested, but there was another side to the interactions that took place. Outposts and border regions often became centers for commercial and technological innovation. This was because different cultural groups connected and many non-military exchanges occurred.
intensifying collective learning. We see this accelerated change very clearly in Europe when the Roman Empire splintered into a series of small, competitive states. This increase in commerce and the exchange of ideas drove a transition of power from large agrarian civilizations to these smaller commercial states. The pace of collective learning further intensified. Traditional agrarian civilizations in other parts of the world lost power and in many cases were colonized by these same European states, with dramatic implications for today's world. Empires were shaped less by physical borders and more by spheres of commercial influence. The modern world had begun to take shape.
Thanks for watching.